Believe it or not, this equation actually represents a hyperbola. However, we can't find any of the important stuff about this hyperbola in the form that we have right now. We want to get it into graphing form. Just like with parabolas, circles, ellipses, we're going to need to complete the square. Once we have it in graphing form, think of all the great stuff we can find. We can find where the vertices are, we can find the transverse axis, we can find the center, and those are all important information, pieces of information that we need about hyperbolas. How do we know it's a hyperbola? Well, let's look at our terms. We have an x squared term and we have a y squared term. There is a negative sign, which means that we have a hyperbola as opposed to an ellipse. The numbers don't have to necessarily be different. It's the negative that's important in this case. Now we have to complete the square, and just like when we completed the square for any other conic section, I'm going to gather my x terms, gather my y terms, and move everything else to the other side. So we get x squared plus 2x. And then for our y's, we're going to have negative 9y squared plus 18y equals 17. Now thankfully for our x terms, we're ready to go. We don't have to factor anything out. But we do for our y terms, so that's why I didn't write my plus somethings yet. This means we're going to have x squared plus 2x plus something. And for our y's, we need to factor out negative 9. This means we're dividing their y terms by negative 9, so we get y squared minus 2y plus something equals 17 plus something plus something. Now, why did it become negative 2y? Well, we started with a positive and we divided it by a negative, which is why we ended up with negative 2y. You can think about distributing backwards. Negative 9 times negative 2 is going to get you positive 18. So let's go ahead and let's complete the square using b divided by 2. So for our x case, it's going to be 1, and then that squared is 1. So we're going to add 1 to the other side as well. Now with our y's, we have to remember that negative 9. So we're going to do b divided by 2, which is negative 1. Squared is 1. But we did not add 1. We really added negative 9 times 1. So negative 9 is what goes on the right-hand side. Now that we have all those numbers on the right-hand side, we can simplify. 17 plus 1 minus 9. 17 plus 1 is 18. Minus 9 would get me back to 9. Just like with the ellipses, hyperbolas always equal 1. So what we have to do is divide that side by 9, which means we have to divide the left side by 9 as well. So we want to think about fractions. We're going to have x plus 1 squared over 9 minus, well, the 9's cancel, so we're going to have y minus 1 squared over 1. You don't have to write over 1, but I like to write over 1 so that that's going to help me actually graph and find information about my hyperbola. Equals 1. Now we have it in standard graphing form. From here we can see the center, we can find where the vertices are based on the fact that it's under x, and we could actually graph the entire hyperbola. That's why it's important to be able to convert forms so that you can actually answer questions about the shape that you have. So here we have another equation, and we want to see what conic section it represents. To see if it represents a hyperbola, we need an x squared and a y squared. We have both of those, and we need one of them to be negative. In this case, the x's are negative. Since we know that these two things are true, we know that we have a hyperbola. To get it into the general graphing form, we need to complete the square. So we need to gather all the x terms and the y terms and move everything else to the other side. Since y is positive in this case, I'm going to start with the y's. So we have y squared plus 4y. And then for our x terms, we have negative 16x squared plus 96x And when we move that 124 to the other side, it's going to become positive because we added 124 to both sides. So now we can complete the square. For the y's, we don't have to worry about factoring, but for the x's, we do. So we have y squared plus 4y plus something. And for our x's, we have negative 16 times, this means we're factoring out negative 16, so you need to do 96 divided by negative 16. So we get negative 6x plus something. And on the right-hand side, we have equals 124 plus something plus something. We have two blanks on the right-hand side because we have two blanks on the left-hand side. So now when we complete our square, we're going to have y, b divided by 2, plus 2, squared is 4. Since we added 4 to the left-hand side, we need to add 4 to the right-hand side. Now our x's. So we have negative 16 times b divided by 2 is negative 3. Squared is 9. But we didn't add 9. We added negative 16 times 9. So we need to find what negative 16 times 9 is. In this case, negative 16 times 9 is negative 144. All right, so we can go ahead and simplify that right-hand side. Here's what you're going to need to do. 124 plus 4 minus 144. So we get negative 16. Don't worry about that too much yet. So now to get it into graphing form, we need equals 1, which means we're going to need to divide the right-hand side by negative 16, which means we also have to divide the left-hand side by negative 16. So now we're going to end up with negative y plus 2 squared over 16 plus x minus 3 squared over 1 equals 1. We're not used to seeing hyperbola equations written this way, so you can always switch them around if you want. We get x minus 3 squared over 1 minus y plus 2 squared over 16 equals 1. And now that we have this final graphing form, we can find all sorts of things about our hyperbola, including the center and the vertices and the conjugate axis and the transverse axis and all of that stuff. This is, again, why being able to convert is a very, very important skill. For this equation, again, look for the things you need to recognize that hyperbola. We need x squared and y squared, and we need one of them to be negative. We have that, so we know we have a hyperbola. We need to gather all of our x terms together and gather all of our y terms together so that we can complete the square. So I'll just start with x this time. We have negative 4x squared minus 16x, and then our y terms are going to be positive 16y squared plus 32y, and then the 64 was already in the right side for us, so we're good. Now we're going to have to pull out or factor out a number from both terms. That's okay. So for our x's, we're going to have to factor out negative 4. So we're going to have x squared plus 4x plus something. And for our y's, we're going to have 16 times y squared plus 2y plus something. And on the right-hand side, we're going to have equals 64 plus 2 somethings, because we have 2 somethings on the left-hand side. So now let's go ahead and complete the square. For our x's, we need to do b divided by 2. In this case, it's going to be 2 squared, and that's 4, We didn't really add 4. We added negative 4 times 4, so we added negative 16. For our y terms, we'll do the same kind of thing. Plus 16 times y, b divided by 2 is 1, squared, and square it, so we get 1. We didn't really add 1, we added 16, because 16 times 1 is 16. So now when we simplify the right-hand side, we're just going to be left with 64, because those two 16s will cancel each other out. So the last thing we need to do to get it into graphing form is divide them, both sides, by 64. So we're going to start out with negative 4 over 64. So you need to divide 64 by 4, and you should get 16. So we have, for our x's, the fraction negative x plus 2 squared over 16. Now we need to do 16 over 64, which is 1/4. So we have plus y plus 1 squared over 4 equals 1. Just like with that last example, if you want to flip them around to have the graphing form you're used to, you can definitely do that. So you get y plus 1 squared over 4 minus x plus 2 squared over 16 equals 1. And looking at this equation now, we can see that we have a vertical hyperbola. We can find the center, we can find the vertices, we can find the length of the transverse axis, we can find all of the stuff that we need in order to answer problems about hyperbolas. This is the last example we're going to look at. Now, let's identify the fact that it's a hyperbola by looking for an x squared and a y squared. And then let's also look for that negative. We have it. It looks a little bit different from the others because we don't have a lot of terms. In fact, we don't have an x term or a y term, which means we're not going to have to complete the square. And we actually almost have graphing form. We know that we need our graphing form to equal 1, and in this case it equals 24. If we wanted the right-hand side to equal 1, we would need to divide it by 24. Now remember that you need to divide both sides of the equation by 24. So when we do this, we're going to have 3 over 24, which is 1/8. So our x is going to be x squared over 8. And when we divide our y's, 6 over 24, we're going to get negative 1/4. So we get minus y squared over 4 equals 1. And there we have graphing form. So it's not always necessary to complete the square. Most of the time it will be. But in this case, since the center is 0, 0, we didn't actually have to. We still needed to do some work to convert it to graphing form. Because if you compare these two forms, look at the first one we were given and the one we have now, you can find a lot more information from the graphing form than you could from the original one. So converting to graphing form for hyperbolas is just like converting for any of the other conic sections. You need to use the method of complete the square to get the equation into graphing form. And once you have graphing form, you can solve lots of problems about that particular hyperbola.